All right, pre-calc, we are going to do the third day of graphing the sine function, and basically what we're going to be doing today is putting amplitude and period together into one problem now. So first of all, we're going to start off by going back to what we did yesterday with the um, sine of bx or b theta, where we have some number in here that will affect the period of the function. So we're going to start with a 1 period interval from 0 to 2 pi and move it around from there. Also, if you remember, like I said yesterday, we can rewrite this as sine of 1 over 6 times theta, and that gives you a more obvious look at what b is. All right, so we're going to start off with our parent function, which is sine. And again, hopefully you've seen enough of this that you know exactly what it looks like. All right, so the parent function, f of theta is equal to sine theta. That's an n. So again, we have our points on the y-axis are at 1, 0, and -1. And this 0 is going to serve as the y and x coordinate for 0. On the x-axis, we have our pi over 2. We got a pi. Put that line there, pi. We got a 3 pi over 2. And we got a 2 pi. All right, so our graph starts out at the point 0, 0. And again, these values come from your unit circle. But again, even if you don't know where they come from, that's okay. Just memorize this graph. This is your parent function for sine. And this is what it will look like every time we graph sine. It's going to look like this. Okay, so that's your sine function. All right, next, we are going to do this 1/6. All right, so I'm going to come over here. These should be straight lines. I'm having a rough time trying to do the graphs on this thing. These are coordinate planes, so these should be straight lines. So do the best you can. It's kind of lagging there for a second. All right, so our f of theta here is the sine of theta over 6, or 1/6 theta. However you want to look at that, it doesn't really matter. Either way, this is not affecting the y coordinates. This is affecting the x coordinates. So again, I'm going to start off by putting 1, 2, 3, 4 lines on here. And I am starting with my 0. So there are 5 points here. We're just starting with 0 and going up from there. So the first thing I'm going to do is actually find out the last point, okay? We're going to find out the period of the function, and that will actually give us our last point here. So to get the period, what we do is we take 2 pi, and we divide that by the absolute value of b. Now, for everything that we do, b is going to give us a positive number, so we don't really need to worry about that. The other way, and the better way of looking at this, is multiplying it by the reciprocal. So multiplying it by 1 over absolute value of b, which is just saying multiply by the reciprocal. So b in this problem, since we have pi over 6, b is 1/6. Like I said over here, we can rewrite it like this. So b is 1 over 6. So think in your head, what's the reciprocal of 1 over 6? What do we get if we flip that fraction? Well, we're going to get 6 over 1. So we're going to take 2 pi over 1 and multiply by the reciprocal of 1 over 6, which is just 6 over 1. Good. So 2 pi times 6 gives you 12 pi, and 1 times 1 is 1. So we just get 12 pi. So that's my last point there, 12 pi. You can see that this is stretched out a lot because this originally was at 2 pi. So 12 pi, that's stretched out a bunch. All right, so let's run through the rest of these points. First up is 0. So 0 times the reciprocal of 1/6, which is just 6 over 1. 0 times anything gives me 0, so that is 0. So my first point is still at 0. The next point was at pi over 2. Now we're going to multiply this by 6 over 1. Let me extend my screen here a little bit. Okay, so multiply this. Well, 2 goes into 6 3 times, so I'm left with 3 pi. All right, that's my next point, 3 pi. keep in mind that we need to have a pattern here as well. Okay, so if this was 3 pi, if we keep going in increments of 3 pi, this should be 6 pi, 9 pi, and 12 pi. All right, so we're going to verify that here. So take our next point, which is at pi. So I'm going to take pi and multiply that by 6 over 1, which is 6 times pi is just 6 pi. So 6 pi is going to be my next point. And again, we're going 0 to 3, 3 to 6. So this should be 9 pi. We're just going to verify that here by taking our next point, 3 pi over 2. All right, so let's take our next point at 3 pi over 2 and multiply that guy by 6 over 1. And again, 2 goes into 6 3 times. 3 pi times 3. 3 times 3 is 9 pi. So we did verify that that is the correct answer. All right, now one thing I did not do in the notes from 442 was label the frequency. So we know here from what we just did that the period is 12 pi. So the frequency is, again, just the reciprocal of this. So the frequency is the reciprocal of this. So that is 1 over 12 pi. Okay, and what that means is it will take 1 over 12 pi units for this, or for it to complete 1 unit. Okay, I'm going to talk about what frequency is a lot more later on. Right now we're just going to label what it means and what it is. Not what it means, sorry, just what it is. So period and frequency. Period we did yesterday, but frequency we did not. So I wanted to list that here. It's just the reciprocal of period. All right, so let's put this on the graph. And again, it will look the same for what we're doing right here. But for, if we were to graph this on the same thing, we could see that it is stretched out a lot more. Here, our last point was 2 pi. Here, my second point is 3 pi. So 2 pi would be in here. So this entire blue graph, 0 to 2 pi, would go from here. 0 to 2 pi would be like right about here. Okay, so you can see how much it's actually stretched out. So up first, my first point, 0, that stayed at 0, so that's right there. The next point, pi over 2, well, that got moved over to 3 pi. So, oops, sorry, back up. So it's at 3 pi. I didn't want to put a mark there. It's at 3 pi, and that point was at 1, so it stays at 1. The y coordinates are not changing here. It's just the x coordinates, okay? So the next point was at pi 0. Well, pi got moved over to 6, so that's at 6 pi 0. The next point, 3 pi over 2, was at negative 1, and now that got shifted to 9 pi. So I have 9 pi negative 1. And the last point, 2 pi 0, well, that got shifted over to 12 pi 0. All right, so here is what our final graph will look like for this, for this function. Let me back up and try that again. The first part looked good. That second part was just a little bit off. That's not great, but it's better than before. All right, so there's your final graph. And again, these will look very, very similar until you graph them on the same coordinate plane. All right, so let me switch over and show you what these look like on the same coordinate plane real quick. All right, so if we look at this graph right here, the red graph is just your regular sine function. Okay, the red graph is just your y equals sine x. So if I zoom way, way out, we could see the blue graph is still following the same pattern. Let me get rid of the red graph so we can see it. So you can see the blue graph is following the same pattern, but it's just stretched out a lot more because this is going 0. Over here is almost 20. And then it comes back up right around here, which looks like about, I don't know, 37 or so. So you can see how much it's stretched out. It takes almost 37 for this to get back to 1 complete rotation. Okay, where the original sine graph, if we zoom way in here, we could see that it takes about 6, a little over 6 units for it to get back, which 2 pi is about 6. So that kind of makes sense there. So anyway, again, I just wanted to show you with an actual graph instead of me just drawing it over one over the other one, how these actually compare. Okay, so we can see here going from 0, we go up, down, back up. Right here is where it starts to repeat. And if we look at the red graph, how many times does that repeat right here? Okay, so if we go up, down, up, there's 1, 2, 3, 4, 5, 6 times. Well, that's kind of odd because the number that we had in our function was a 1/6. So it's not coincidence. There's a reason why, because that's the number of times that that cycle will repeat itself in that new period of the function being moved around. All right, so let's move on here. So again, I want to bring this up here. We are going to do two things. Actually, we're going to do all of these. We will bring in frequency here and mention this as well. But we are going to be putting these graphs together. Okay, we're not really talking about frequency in terms of the graph, but amplitude and period. We're going to do two examples of putting these together, and we're going to do these in order. Okay, just like we did before with the systematic graphing, there is a specific order that they need to be done in, and we will do those in that order. Okay, so let's go ahead and get started on this first one here. I will do these graphs in different colors just to kind of help it just to help it look a little better. So my parent function will be in blue. So this is my f of theta is equal to sine theta. Sorry. My next function, I'll do that in green, and that is going to be the 1/3. And then my third function will be the period, which will be incorporating that 4, and that'll be the last part of this graph. Okay, so let me start off with my parent function. Again, same parent function we've been using since the beginning of the 441 notes. So nothing new here. Pi over 2. Next one is pi. Next one is 3 pi over 2. And the last one is 2 pi. So we're going to go, again, starting out at 0, 0. Pi over 2, sine of pi over 2 is 1. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. So again, here is our parent function. There we go. All right, up next, we will do the 1/3 part. All right, now 1/3, so f of theta is equal to, that should be an equal sign, 1/3 sine theta. And again, just like when we did these other graphs, when you're doing these, you have to make sure you have all these parts. You have your equation, you have your graph, you have the y coordinates and your x coordinates. You need to have everything, okay? Don't just put random numbers and random graphs down. This is what they should be looking like, all right? So if you're not putting these correct graphs down, you're not going to be getting credit for these. You got to make sure they look like this. So anyway, the 1/3, this number in front here, this affects the amplitude. So I'm going to write that above it. Amplitude, well, I'm going to abbreviate it, AMP. The amplitude is the absolute value of that number, 1/3, which in this case is just 1/3. All right, we want to make sure we're labeling that. So your amplitude is 1/3, which just means that our graph, instead of going from 1 to -1, is going to go 1/3 to -1/3. So it's going to squish it down to the x-axis. Okay, it's going to be a third of the original height. All right, so when we do this, I'll make it look shorter, but I'm not going to make it look a lot shorter because then it just kind of gets a little messy with the graph. But I'm going to say right here's my 1/3, and down here's my -1/3. My x coordinates are not changing, and this is where it gets kind of messy if we make it too much smaller. So this is still pi over 2. You know what I can do, though? Let me come back in here for a second. Wrong button. Let me change the thickness of this so I can actually make it a little bit smaller here. This is pi. We have 3 pi over 2. I can make it a little bit of a skinnier lines there if I change the thickness of that. So, all right, so I'm going to change it back to do my graph here. So I'm going to do this one in green. Now remember, all of your y coordinates get multiplied by this number, okay? 1/3. So I'm multiplying all of my y coordinates by 1/3. So we can do this. This is not hard. We're just multiplying by 1, 0, or -1. Those are easy numbers to multiply by. So first up, we have the point at 0, looking at the y coordinate, not the x coordinate. The y coordinate is 0. Well, what's 0 times 1/3? That's just 0. That's not hard. That's 0. 0 times anything is 0. Next up, this point at pi over 2, it was at 1. Now, multiply by 1/3, it's going to get moved down to 1/3. Next up, the point at pi was at 0. So 0 times 1/3 is, you guessed it, 0. Next up, 3 pi over 2 was at -1. What's -1 times 1/3? Well, that's -1/3. Okay, I'm going to back that up because that's actually a little bit lower than I want it to be. All right, about there we go. And the last one at 2 pi was at 0. So 0 times 1/3 is 0. So there we go. And again, this will be a shorter graph. It's going to be a little bit smaller. Okay. Now, the last function, we'll do this one in red. The last function is dealing with the period. So again, the period, we're going to go ahead and take 2 pi, and we're going to divide that by the absolute value of b. Well, what's b in this function? The number in front of your variable, theta, the number where the red dot is there, which is a 4. So we're going to divide that by 4. So 2 over 4 is 1/2, so pi over 2. All right, now what that means is that for our function, let me write down our function here, f of theta, we're going to still incorporate the 1/3 into this, sine of 4 theta. All right, so what is this going to do? Well, first of all, let me scroll this up here a little bit. The first thing we want to do is just recopy. I messed that one up again. Let me try again here. We want to recopy our y coordinates because they're not changing. Okay, we're still doing 1/3 to a -1/3. What is changing is all of our x coordinates. So I'm going to put my 4 dashes here. Okay. And what I'm going to do is I'm going to go through and solve all of these by doing exactly what I did up here. Instead of 2 pi, though, I'm taking all of these x coordinates. So we're going to start by, and instead of dividing by 4, I'm going to multiply by the reciprocal. So think in your head, what's the reciprocal of 4? Well, that's 1/4. So I'm going to multiply all these values by 1/4. So here we go. First up, 0 times, that doesn't look like a 0, that looks like a pi, theta, sorry. 0 times 1/4 is 0. So my first point is still at 0. Next, my second point is pi over 2. So take pi over 2 and multiply that by 1/4. Pi times 1 is pi. 2 times 4 is 8. Okay? Pi over 2 times 1/4. Now, this is the same thing. Don't think that I'm doing something different here, okay? I'm doing the same thing. I'm taking the point, which is pi over 2, and I'm dividing that by 4. But hopefully you can see that this is a mess right here. Doing this is just an absolute mess. So the easy thing to do is multiply by the reciprocal. Multiply by the reciprocal. These cancel, and I'm just left with this, which is exactly what I did right here, okay? So don't think I'm doing something different. I'm not. All right, so this is pi over 8. Also, let's fill in our last value here. We didn't even do that. This is pi over 2. Okay, that's what we got right here from our period, pi over 2. Okay, so let's keep going with this now. The next point was pi. So let's take pi and multiply that by 1/4. Well, this is like pi over 1, so pi times 1 is pi. 1 times 4 is 4, so my next point is pi over 4. So pi over 4, there we go. Oops. Try and extend this. All right, we have one more point that we need to do, and that's at 3 pi over 2. So let's do that one. 3 pi over 2, and we're going to multiply this by 1/4. So think in your head, 3 pi times 1 is what? 3 pi. And 2 times 4 is what? 8. So we end up with 3 pi over 8. All right, so there's our 5 points. 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. And again, like I said, there is a pattern here. It's just harder to see when we have multiple denominators. So it's pi over 8. This is 2 pi over 8, 3 pi over 8, and 4 pi over 8. Okay, they all reduce to those values. So again, there is a pattern there. All right, so last thing we got to do is connect our points here. So let's go ahead and do this. The first point was at 0, 0, and that got moved to 0, 0. Good. Next up, pi over 2, 1/3. Well, pi over 2 right here, pi over 2 got shifted over to pi over 8. So pi over 2 moved to pi over 8. So there's our new point. Next, pi. Well, pi got moved to pi over 4. So pi was at 0. That means pi over 4 is at 0. Okay, and again, just remember, this has to look the same. What we have here in this green graph, it has to look the same. We haven't changed the look of it. We just changed how it's spread out, which basically just means we changed our x values. All right, next up, 3 pi over 2. Well, 3 pi over 2 got moved to 3 pi over 8. So 3 pi over 2 at negative 1/3 gets moved to 3 pi over 8, negative 1/3. Now mine's going to kind of run into that, but that's okay. And up here we saw that 2 pi was moved to pi over 2. So my last point is right there. And also we got to end up where we started. So here is our last graph. There we go. All right. So we did the amplitude, we shrunk the graph down, which just means we multiplied. Well, I'll write this down here, multiply y by a. Over here, we kind of divided, and what we did was we divided the x divided by b, which is the same thing as multiplying by the reciprocal, okay? This is a divided by symbol, divided by b, which is, like I said, same thing as multiplying by the reciprocal, okay? So we're going to do another example together, but again, one thing I want to list here before we move on is the frequency, okay? So if the period is pi over 2, what is the frequency? Well, it's just the reciprocal. So the frequency here, oops, that's a G. I erased too much. The frequency is going to be pi. Nope. Let me back up again. Pi over 2 is the period, so the frequency is going to be the reciprocal of that, which is 2 over pi. All right, so there we go. There's our 3 steps. Here's our parent function. So parent, here's step 1, step 2, which is our final shift. All right, one more example that we're going to do here together. And again, I will start off with our parent function, f of x equals sine x. And we will have 2 graphs again. So if we look here, my green graph will be the negative 4. Okay, and the negative 4, again, we're going to multiply the y values by negative 4. Next, I will do the 1/3 for b. And again, if you want to rewrite this, next to it, we can just say this is the same thing as negative 4 sine 1/3 x. Okay, those are the same thing, all right? So 1/3 is b, and that's what we'll do in the red graph. So, all right, here we go. Parent function, one more time. 1, negative 1. We got our pi over 2. Change the thickness. There we go. All right, so first up, pi over 2. Next, pi. Next, 3 pi over 2. And the last one, 2 pi. There we go. Change it back to blue. Here's our graph, 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. So connect the dots. There we go. All right, there's our parent function. Again, nothing really changing at all there. For our first shift, change, translation, transformation, whatever you want to call it, doesn't matter. We are going to do the amplitude. So let me write amplitude is the absolute value of A, which in this problem is -4. So that means the amplitude is 4. So what that means is that half of the height will be 4. Over here, the amplitude was 1 because the number in front of sine x is 1. So we can see that half of the graph, half of the height of the graph is 1. The overall height is 2. It goes from -1 to 1. So half of that is just 1. So let's go through and graph this now. So we will stretch it out because it's going to go from 4 up to -4. All right, so we're going to be 4 all the way down here to -4. Now we have not changed our x coordinates at all. All right, they are still the same. Pi over 2, pi, 3 pi over 2, and 2 pi. All right, so let's graph this here now. First of all, we're going to start with each of these points and look at their y coordinates. Each y coordinate will get multiplied by -4. All right, so every y value gets multiplied by -4. So first up, the y coordinate right here is 0. Well, 0 times -4 is 0. Up next, pi over 2. Where was pi over 2? That was up here at 1. So 1 times -4 is -4. So that's actually going to go down to -4. So you can see the flip there, which the flip happens because there is a negative out front. Up next, we have pi. Well, pi is at 0, and 0 times 4, 0 times -4 is 0. Up next, we have 3 pi over 2. Well, 3 pi over 2 is at -1. -1 times -4 is a +4, so that's going to be up here. And the last point at 2 pi, well, 2 pi was at 0, so that's going to drop back down here to 0, because 0 times -4 is still 0. So here's our new graph. There we go. So that is our first point there. Our first graph after we stretch that out. Next, we are going to do the period, which is 2 pi divided by the absolute value of b, which is 2 pi divided by b in this case is 1/3, which is the same thing as 2 pi times the reciprocal, which is 3 over 1. Just showing you a bunch of different ways to do the same problem. Either way, we get 6 pi. Okay, so let me first of all come back here. I did not write in the function here, so let me write that in. F of x equals -4 sine x. Our graph for this one, or our equation, I should say, f of x equals -4 sine, and I'm going to write that the way it was originally given to us as x over 3. You can write it as 1/3 x if you want to, but I just like to write it the original way it was given to us. So, all right, so I'm going to fill in my y coordinates. So 4 and -4. But then I will just put in so I have my 1 point here at 0. Then I got 1, 2, 3, 4. All right, now I know that I'm going out to 6 pi. That's my last number, 6 pi. But I got to figure out the other 4. First one's always real simple. 0. Instead of doing 0 divided by 1/3, I'm going to multiply by the reciprocal, 3 over 1. And that's still going to give me 0. So no surprise there. That's what it's always been. So 0. Up next, pi over 2. So I'm going to take pi over 2, multiply by the reciprocal of 1/3, which is 3 over 1, to give me 3 pi over 2. So here's my first point now at 3 pi over 2. Which we can see here, that's where this point was right here. So we can see how much this graph is stretched out. My second point is all the way out here at 3 pi over 2. All right, so let's keep going here. I'm just going to draw some squiggly lines to separate this so I don't have to scroll down more. My next point is at pi. So pi, you can put pi over 1 if you want to, times the reciprocal of 1/3 is 3 over 1, which gives me a grand total of 3 pi. So that's my next point, 3 pi. And the last one that we need to do here is 3 pi over 2. Okay, my next point here at 3 pi over 2, multiply that by 3 over 1 to give me 3 times 3 is 9 pi over 2 times 1 is 2. So there's my the last point that I had to do was not a 3, it was a 9. Sorry, let me back up here again. 9 pi, sorry, my computer just kind of glitched out there for a second. 9 pi over 2. All right, so let's put this all on the graph here now. Let's get this on the coordinate plane. So the first point was at 0. That stayed at 0. At 0, there we go, is our first point. Pi over 2 was shifted to 3 pi over 2. So that point is down at -4 because that's where it was right here. We're not going back to the original. Okay, we're not going back to the blue graph. We're going back to the green graph. We already moved it one time. Up next, pi was shifted to 3 pi, so we got a point right there. And 3 pi over 2 was moved to 9 pi, so that point's going to be way up there. And the last one, 2 pi, was moved over to 6 pi, so that point is right there. So let's connect the dots. And there we go. There's your final function. One more thing we want to do here is label the frequency. So again, frequency is the reciprocal of period. Since the period was 6 pi, our frequency will be 1 over 6 pi. All right, so you got amplitude happening in the green graph, period happening in the red graph, which actually the period and the frequency both happen in the red graph. We're just not really talking about frequency as far as the graphing part of it. We're really just talking about the period when we do that part there. So again, like always, we're putting together the 441 notes with the 442 notes now and doing examples that have both of those steps in it. So like I've been saying all along, if there is any of this stuff that you are confused about, you need to make sure that you're asking. Just make sure that you're keeping up with this stuff, and you let me know if you have any questions. So send me an email or send me a private comment, and I will get back to you.